In this video, we'll look at the nitration of benzene reaction, and I'll show you the mechanism. This reaction is the first example of an electrophilic aromatic substitution reaction. So in this reaction, we're going to add benzene together with nitric acid. In the presence of a sulfuric acid catalyst, we're going to create nitrobenzene. Now, of course, as we've previously seen with our electrophilic addition reactions with alkenes, we can add on an electrophile such as hydrogen chloride, and we add the electrophilic hydrogen to one end of our alkene, and the more nucleophilic chlorine gets added to the opposite end of our alkene. So our product then loses the original alkene double bond, and we add on the hydrogen and the chloride. In the case of aromatic rings, this is unfavorable due to the loss of aromaticity that would be associated with replacing that double bond. So rather than losing our double bond, we're going to do an electrophilic aromatic substitution, where we're going to replace the hydrogen on our benzene ring with our new electrophile. So to begin with our reaction, we're going to start out by preparing our electrophile using sulfuric acid. We start out with our nitric acid, and our sulfuric acid, and our sulfuric acid will now protonate the nitric acid, once we've protonated the nitric acid, we then have our perfect leaving group, and our nitric acid will kick off our water leaving group to create a nitronium ion and, of course, water as our leaving group. Our nitronium ion with that central positively charged nitrogen now becomes our strong electrophile for the electrophilic aromatic substitution. Once we've formed our electrophile, we can now proceed with our electrophilic aromatic substitution. So we take our benzene ring now. We're going to have a single hydrogen, which will be substituted in our reaction. So this is going to be replaced by our new electrophile, which is, of course, the nitronium ion. In the first step, which is our rate limiting step, we're going to use the extra electrons from our benzene ring to attack our nitronium ion electrophile. This results in what we call an arenium cation. So we have a positive charge, and we've lost the aromatic structure of our benzene ring. So this is what creates this rate limiting step where our reaction is slowed because of the unfavorability of producing that rhenium cation and losing our aromatic ring. So we need a very strong electrophile, such as our nitronium ion, to undergo this reaction. Once we have added on our nitronium ion, we can then eliminate our rhenium cation by kicking off our hydrogen. So we're going to bring in our water, which again was the other product of our initial reaction between sulfuric acid and nitric acid. And we're going to deprotonate and restore our aromaticity. So once we've eliminated that hydrogen, we then recreate our double bond, and we have our nitrated benzene ring. Again, this is our first example of an electrophilic aromatic substitution reaction. We'll see several other examples of electrophilic aromatic substitutions in our upcoming lectures. They'll all follow a very similar reaction mechanism, although the exact group that we're substituting on for our original hydrogen will vary.